Hola amigos! Today I'm so excited because we're going to go ahead and learn how to divide numbers using the partial quotient method, or what some people might call the big seven. Now you may be asking yourself, well, why the big seven? But if you look at the symbol right in front of you, you see that there is a big seven, and hence the name, right? So one of the reasons why students tend to like this method as opposed to the traditional or long division is because it avoids all the different mistakes that students typically do when doing long division, because the structure is a little tricky. There's a lot of steps when it comes to long division, and sometimes kids subtract before multiplying and so on. So the big seven really does a great job in eliminating that, and actually just focusing on the repeated subtraction, which is what division is, right? Division is repeated subtraction. Before starting on the steps, I do want to go ahead and compare the traditional division method or long division with the partial quotient, because it does have different structures. As you can tell, the symbol that represents divisions are different, right? So in traditional division, we have the division symbol that you've probably seen before, but with the partial quotient or the big seven, you have a big, literally a big seven, right? You will find the divisor is in the same location. So notice they both have the 5 on the outside of the symbol, and then they have the dividend on the inside. So this is pretty much the same here. But when it comes to your quotient, in long division, the quotient goes above the symbol, but with the big seven, you have partial quotients on the outside, which at the end you're just going to have to add them together. So let's go ahead and see and start with step 1. For step 1, we're going to go ahead and we're going to draw the big 7, and we're going to position my divisor on the outside of the 7. You're going to place your dividend on the inside of the 7, just like you would with long division. Then for the third step, we're going to think and write down what multiples of your divisor do you know? What times table do you know? These will become your benchmark numbers, right? So just for this example, for argument's sake, I'm going to put down that these are the only times table of the 5 that I know. 5 times 1 is 5. 5 times 5 is 25. 5 times 10 is 50. 5 times 20 is 100. Let's just say that those are the only multiples that I know. For this part, ask yourself about how many 5s are on 46. Well, I know that 5 times 4 is 20. I'm not really sure what the other times table are, but you know what? I'm going to say that there has to be at least 4 of them, since 5 times 4 is 20. So I'm going to go ahead and I'm going to put my 4, the times that it fit in at least, on the outside, and that's going to become a partial quotient. Then I'm going to go ahead and I'm going to multiply your divisor, the 5, by your partial quotient, which is 20, and I'm going to subtract that from your original dividend. So 46 minus 20 is 26. This number, the 26, is the amount that still has not been grouped. Notice that the 20, we're going to get rid of it because we already grouped those, so we don't need them anymore. Now we're going to focus on the 26. So in this case, we see that there's still 26 left. Since 26 is bigger than our divisor, the 5, we must continue dividing. Next, we're going to ask ourselves again about how many 5s are in 26. Well, I know that 5 times 4 is 20, so there's at least another 4 5s in the 26. So I'm going to put my 4 once again. I'm going to place the partial quotient, the 4, on the outside of the 7, and I'm going to multiply my 4 by the divisor, the 5. Once you do that, you're going to go ahead and subtract your 20 from your 26 to once again find out what's left. And there's still 6 that has not been grouped. Notice that 6 is bigger than the 5, so you must continue dividing once again. Ask yourself about how many 5s fit in 6. Well, I know that 5 times 1 is 5, so it fits at least once. So I'm going to go ahead and I'm going to place the 1 outside the 7, and I'm going to multiply 5 times 1, and I'm going to subtract that from my 6 to find out what's left. 6 minus 5 is 1. Since the 1 is smaller than the divisor, the 5, we know that we can now stop dividing. Now we have to add all the partial quotients together to get our final quotient. So 4 plus 4 plus 1, we get 9. So your final quotient is 9, but of course we can't forget our 1. Remember that was left, that couldn't be grouped. So therefore our final answer is 9 remainder 1. As I said before, the more you know your multiples, the easier the process gets. So let me show you what I mean. Look at this problem. Since I know that 5 times 9 is 45, then I can skip all the repeated subtraction and only subtract once. Because 5 times 9 is 45, I would put my 9 on the outside, and then I would go ahead and multiply 5 times 9, which is 45, and subtract it. 46 minus 45 is 1. So notice that I will still get 9 remainder 1. Now, what about if you only know 5 times 1 and 5 times 2? Notice that you have to do much more subtraction. It's much longer, but you would still get the same answer because 2 plus 2 plus 2 plus 2 plus 1 is still 9, and you still have a remainder of 1. So either way you do it, you'll still get the same answer, but the more you know your times table, the less work for you. So I hope that this method really open up your mind and your understanding of division. And if you need more practice, just change the numbers around and just continue repeating the process. And in no time, you'll be an expert. If you enjoyed this video, just go ahead and smash that thumbs up button below and share it out with your friends, teachers, or even parents. Also, make sure you hit that subscribe button and the notification bell so that you don't miss any future videos. Thank you for watching.